So in this video, we'll be trying to find the resultant force, resultant angle, and also to draw the diagram of the resultant force for this system given here. All right. Now, how do we solve this question? Now, if you look at this, this is different from the previous examples that we've been doing where we are given an angle. For this case, if you observe the diagram, no angle is given here. Instead, you're given different shapes like this with their dimensions. So how do you solve this question? I've said that your first task, as usual, is to draw your free body diagram. Okay. Now, for this case, let's start with this. For the free body diagram, you have this part here. That's your x-axis. And you have this part here. That's your y-axis. All right. Your first force you're given here. Let's start with this one here. The first force I'm having here is this one here, 106 pounds. Now, for convenience sake, right, we'll take pounds to be equal to Newton, all right, for convenience sake, and then we'll take the inches as being equal to, or inches, um, inches as being meters, all right. So this is inches with pounds, which is the same thing as Newton and meters, all right. So let's use the distances as meters and the forces as pounds. The forces as pounds given here, we'll take them as Newton, and then we'll take inches, which is distance, as meters, just for convenience sake, okay. All right, with that being said, let's see how we can solve this. The first force I'm giving here is 106. I'll take it as Newton instead. This is 106, so you have this case here going this way. And in this case, what I have here is 106. So I'll take this as 106 Newton. Don't forget it's actually pounds. Basically the same thing. You know, your next force there is 102, this one here. And you can see the direction. So I'll do 102 and see what we get. That's going this way here. This, then you have this as 102 Newton. Finally, the next thing I have there is 200 pounds. So you can see the direction there. So I have 200 pounds from here. I have 200 pounds going this way. Okay, keep this here. This one here was 200. We're using Newton, so 200 Newton, and that's your direction. The next thing you observe here is that we're given distances. All right. To solve these questions like this, your task would be try to get for each of the forces, they are forming something like a triangle. All right. That's your observation. If you look at the first one here, let's use the 106 Newton or pounds. You see this is forming here to this, and then to this, and then to this. So you can see the triangle there. It's a right angle triangle. Also, the 102 Newton or pounds is getting this one like this, and then like this, and then like this. So you can see the right angle triangle. The third one now is giving you this. You can see this, and then perhaps you can go this way if you want to, and then this way. You can now see the three triangles. So what this forms for you is a right angle triangle. That's the observation. So what I'll do here is very simple. For each of them, I'll just form my right angle triangle. This is how to draw your free body diagram. Form your right angle triangle like this way. You could make it full like this if you want to, or you could do it halfway like this. You see the same thing, all right? So whether I make it full like this or halfway, you see the same thing. So I'm saying you can come to the top still and do it like this. That's your right angle triangle. That's fine. But then for convenience sake, I'll just come here and draw this way. So it's like I'm drawing a mini diagram. So that's the first one. For this, I'll draw this triangle here. Now draw this one here. Finally, for this one here, I'll just simply come here and draw this triangle here, which is from here. I'll draw this way like this, and I'll draw this upwards like this, and then draw this way. All right, so basically I now have my triangles here. Now for the triangles, some parts are given, some parts are not given. For example, if you look at the 106 Newton, for the 106 Newton force, you're given this part here, this height here, from here to here. This height here is given as 45 pounds, but we're taking pounds as Newton. It becomes 45 Newton. So this other part here is given as 45. So for this part, if you look at this part here is given here as 45. All right, and it's in inches, and we'll take it as meters. All right, that's the distance in meters. So saying here is simply 45 meters for this. Okay. For the lower part, you can see that the lower part from here to this part here, this lower part here, is already given up here, and we're given the distance there as 28 inches. So I'll simply take that as 28 meters. So here, the lower part of it is given as 28 meters. Okay, let's come to the 102 Newton force, which is this one here. For this one here, observe that the distance from here to here, which is this part here, is already the same thing as this one here, which is 45 meters. So for the 102, that's actually 102. For the 102, what I have here is still 45 meters, as I showed you. Where else do we have? For this same 102 here, if I look at this, the lower part of each triangle, that's from here to this part here, this lower part here, is given as 24 meters. All right, I said we're using inches as meters. So the lower part is 24. That means this part here is 24 meters. All right, let's look at the last one there, 200 Newton. For the 200 Newton force, we said for this, where do we have? Okay, we have this part here. That's from here to here is given as 30. So you can see here, 30 inches or 30 meters. That's the vertical aspect of it. So the vertical aspect of it is given as 30, which is this part here. This is 30 meters. Okay. Where else do we have there? Where else do we have? We have the horizontal part, that's from here to here, which is this distance here, showing the horizontal part, and the value there is 40 in inches or 40 meters. All right, so let's put that as 40. The horizontal part, which is this part here, is actually 40. Let me write it below this. 40 meters. All right, so you can see the way I got all of this. Okay, this is a positive of y, this is the negative of x, this is the positive of x, and this part is the negative of y, so minus y. So I have this. Okay, so we have all of these aspects here. What else do we do? Let's now get the next thing you have to find here is the hypotenuse of each side. All right, if you look at this, they are all right angle triangles. You can say this is a right angle triangle here, this is a right angle triangle, this is a right angle triangle. All right, so we can now find the hypotenuse using the Pythagoras theorem. From Pythagoras theorem, the square of the hypotenuse is equal to the sum of the square of the opposite side and the adjacent side. In essence, the hypotenuse is simply equal to the square root of the other two sides squared. All right. And if that's true, it means for me to get the hypotenuse of each side, I'll just take the square root. So for this part here, I'll just take the square root. It becomes the square root of the other two sides squared, which is 45 squared plus 28 squared. And if you punch this, I'll just get my calculator and punch this very fast. So it becomes the square root of 45 squared plus 28 squared, and that gives you 53. All right, for the first one there, I have 53 as my answer. So literally, this value here is 53 in meters. I have this part. All right, so the first part done. Let's come to this. We'll follow the same principle here. So for the 102 Newton force is simply equal to the square root of 45 squared plus 24 squared. So square root of 45 squared plus 24 squared, that gives you equal to 51. So the answer there is 51. So this part here is 51 meters. Let's look at the last one there. For the last one, what you have there is the square root of 40 squared plus 30 squared. And if you punch that, square root of 40 squared plus 30 squared, your answer gives you equal to 50. That's your answer. In essence, the value here is 50 meters. All right. So with this said, now we've gotten our free body diagram. We can now proceed to solve this. Now, in solving this, recall that the first thing we do is to take the summation of vertical forces, and then we take the summation of horizontal forces. All right, so let's get this done. So let's take the summation of horizontal forces. So summation of horizontal forces. And we said that's simply sigma F force X for horizontal should be equal to what there? 0. Let's start with the first one there. For the first one, the 106 Newton, if you look at this, for this, we'll be taking the angle between this one here, which is between the force and the horizontal line. All right, so you can see this is the force, this one here. This is the horizontal line, this one here. So we said when you're resolving vectors between the force and the horizontal, that the horizontal component is gotten with cos, all right, cos of theta, cos. All right, so if you have this, let's get cos theta and sin theta for each of this. All right, what's cos theta here? Cos theta is equal to, for this, cosine is, if you use the SOHCAHTOA, cosine is adjacent over hypotenuse. All right, for this angle here, considering this diagram here, the adjacent is actually 28 and the hypotenuse is 53. So if you do adjacent over hypotenuse, it becomes 28, which is the adjacent, all over the hypotenuse is 53. By the way, this is the opposite, O. This is the adjacent, A. This is the hypotenuse, H. Right? So that's it. All right, so cos theta becomes adjacent, which is 28, all over hypotenuse, which is 53. Also, sine of theta will be equal to, sine is opposite over hypotenuse. Opposite is 45 meters. That becomes 45, all over hypotenuse is this one here, 53 meters. So all over 53. All right, so we've gotten cos theta and sin theta for the 106 Newton. Let's come to the 102 Newton force. All right, we're also taking this angle here, theta, which is between the force, which is this one here, and then the horizontal, which is this one here. So you can see the theta here, the angle between the force and the horizontal. So with this, let's get cosine of this for 102. For the 102 Newton, cos theta is equal to, by the way, for this particular triangle, this one here, what's the opposite? The opposite is simply the side opposite this theta here, which is this part here. This is opposite. This is your hypotenuse, always constant. This is your adjacent. All right. Now, knowing that I'm using SOHCAHTOA, such that cosine is equal to adjacent, in this case, that's 24, becomes 24, all over hypotenuse, in this case is 51, that becomes all over 51. That's cos theta in this case. Okay, what's sin theta in this case? Sin theta, or better still, let's call this okay, sin theta in this case is equal to, sine is opposite over hypotenuse. The opposite here is 45. It becomes 45 all over hypotenuse in this case is 51. So all over 51. All right, let's get the last one there. For the 200 Newton force, let's get cosine. Cos theta is equal to, again, look at theta here, this part here, where theta is simply the angle between the force and the horizontal line. Right, this is my horizontal line, this one here, this line is my horizontal, this is my force. So the angle between the force and the horizontal is theta, and hence cos theta is equal to opposite. Now, for this angle here, opposite of this angle here is this one here, which is 30. So I'll call this opposite. Adjacent is this part here. Hypotenuse is your longest part, 50. So cos theta is simply equal to is that's adjacent over hypotenuse, which is simply equal to, adjacent is this one here, 40. It becomes 40 all over hypotenuse is what there, 50. Let's take sine of theta. Sine theta in this case is equal to, sine is opposite, that's 30 all over hypotenuse, which is what there, 50. All right, so with this now, we can now proceed to resolve this. Okay, let's resolve this. So we're saying that sigma fx, let's start with the first force there. That gives you sigma fx, and that's equal to, now to make this easier for us, what I will do is just, let's call this theta 1. This becomes cos theta 1 sin theta 1. Let's call the next force theta 2, and this theta 2. This now becomes cos theta 2 sin theta 2. Finally, let's call the third force theta 3. Let's add 3 here, theta 3. This becomes cos theta 3 sin theta 3. All right. For the first one there, let's take the first force there, this one here. If I resolve this to the horizontal, that's push this to the horizontal line, it lands at the positive part of x. So it becomes positive 106 cos theta 1. All right, that becomes 106. That's positive cosine theta 1. All right, so resolving to the x-axis is always cos theta 1. We've explained that in our previous class too. Okay, the next one there, we have there's 102 Newton, which is this one here. Resolve this to the horizontal here, you'd have a negative of x. That becomes minus 102. So this becomes minus 102 cos theta 2. That's theta 2. And then finally, you have this part here. Resolve this way here. That becomes a negative. So it becomes negative 200. Okay, so that becomes minus 200 cos theta 3. Right, at this point here, let's put in values. And that's equal to 106. What's cos theta 1? Cos theta 1 in value is 28 over 53. This into 28 all over 53 minus 102 into cos theta 2. Cos theta 2 in value is 24 over 51. That's 24 all over 51 minus 200 into cos theta 3 is actually this one here, 40 over 50. That's 40 all over 50. So we have this. All right, so we have this. Let's I'll just go through to punching my final answer here. So sigma fx is equal to, so please punch this correctly. What do you have? For me, this becomes 106 into 28 all over 53 minus 102 into 24 all over 51 minus 200 into 40 all over 50. And when I punch this, my final answer here gives me minus 152. Now I'm taking this, of course, this will be in I. All right, I means that it's in the x-axis. And I said instead of pounds, I'm using what there? Newton. All right, so you could use pounds if you want to, but just for convenience sake, I'm using Newton. All right, I've gotten the summation of horizontal forces. Let's get the summation of vertical forces. Summation of vertical forces. Now, by the way, I said I have already treated this from scratch in a previous class. I'll leave a link to the first class where I explained all of this from scratch in the video description. So if you missed our previous class or our first class on the resolution of vectors, where I explain why this is cos and why some of them is sine, I will leave a link to that video in the video description. All right, so check video description for link to our first class on this from the scratch. Okay. All right, let's proceed with this. Let's get the sum of vertical forces. That's sigma Fy. That's equal to, let's go back to the first force there. If I resolve this force to the vertical axis, that's this way here. What I have there is positive y. So it still becomes positive 106. That's 106. I will take sine theta 1 because I'm resolving to the vertical axis. So it's sine in this case. For this other one here, the second force there, if I resolve this now to the vertical axis, don't forget to using vertical or y-axis. In this case, it becomes positive of y. So 102 in this case becomes positive. It becomes plus 102 sine theta 2. The final force, which is 200 Newton, resolve it to the vertical. So I'll have to push this one to the vertical like this. Observe you have a negative y. So negative y then means that it becomes the negative of 200. That becomes minus 200 sine theta 3. We have this. All right, let's impute values. This is equal to 106. What is sine theta 1? Sine theta 1 is 45 over 53. That's 45 over 53. I have 45 all over 53 plus 102. What is sine theta 2? Sine of theta 2 is 45 over 51. That's 45 all over 51 minus 200 into sine theta 3. Sine of theta 3 is simply 30 over 50. That's into 30 all over 50. So we have this. All right, so we have these values here. Let's punch this to get our final answer. That means sigma Fy would be equal to, so 106 into 45 all over 53 plus 102 into 45 all over 51 minus 200 into 30 all over 50. This gives you 60 J Newton. All right, so you have this. All right. All right, so you have this. Now, by the way, let me stress that this can still be written as minus 152 Newton I. It's still the same thing, all right? Still okay that way. So this is also equal to 60 Newton J. That still works. All right, so I've got my answer here. Let's now get the resultant. So therefore, the resultant force, we call it Fr. So we said Fr is equal to the square root, if we use direction here, square root of sigma Fx squared plus sigma Fy, this one here, squared. So we have this. Okay, let me just add the arrowhead here. Come here too, or add up the arrowhead. Okay, come here too, add up the arrowhead. The arrowhead shows direction. Okay, all right, so we have this. That's all of it. Okay, so let's put in values. This will be equal to the square root of, for fx, your value is minus 152. That becomes this into minus 152 all squared plus, for fy, you have 60 Newton. That's 60 all squared. From here, we'd have that fr is equal to, take the square root of, punch this correctly, minus 152 in brackets all squared plus 60 all squared. What you have here is 163.41 Newton. Or if you want to use their pounds, you can now say this, their pounds. All right, so this is like the answer to this question, 163.41 Newton. Or you can use 41 pounds if you want to, as used in the question. So this is my resultant force. Let's get the resultant angle. Resultant angle. For the angle, we said it's simply theta is equal to tan inverse of sigma fx, fy, please, all over. It should be having this all over sigma fx. All right, so this is the formula. That's equal to tan inverse of, what's sigma fy? Sigma fy, the value is this one here, 60 Newton. All right, so that becomes 60 Newton. That's 60 all over sigma fy. That's sigma fy, please. Sigma fx is minus 152 in Newton. That's actually equal to minus 152 in Newton. Okay, let's take the value here. From this is equal to tan inverse of, let's take 60 divided by minus 152. What you have, there's minus 0.39, I'll use 4 decimal places, 3947, and that's equal to minus 0.3947. Okay, tan inverse of minus 0.3947, that gives you about minus 21, about minus 21.54 degrees approximately. Now I've said when you have theta as negative, what it simply means is that this negative is only showing you direction. So what do? Eliminate the negative and just take the value as 21.54 degrees. That's your answer. Okay, the negative there only shows direction. All right, so I have 21.54 as my angle. Let's now get the resultant diagram. So finally, resultant diagram, resultant diagram. For the diagram, let me get my x and y axis. So you have this one here, and you have this one here. Okay, let's see how this goes. Now, to get the diagram correctly, first things first, let me label this as, this is my positive y, this is positive x, this is negative x, and this is the below here. Below here is negative y. Now, to get resultant, if you look at this, observe that in my workings, the fy value was positive. That means the resultant will be in the positive part of y, as you can see here, positive part of y, while for the x-axis it will be in the negative part of x, because my answer here is negative. All right. So positive part of y, negative part of x. Which quadrant is that? Let's look for this. All right. So positive y, negative x is this part here. This is positive y. This is negative x. So here's the quadrant. So in essence, my resultant will be here. All right, this is a positive y axis and negative x. The value of the resultant is, the value is this one here, 163.41 Newton. That becomes 163.41 Newton, or you can use pounds as they did. The angle of the resultant, which is this one here, is given as 21.54. That's 21.54 degrees. So basically, this is how we solve this question. Okay. All right, guys. So for more classes on applied methods like this, do want to visit my website www.jonaemmanuel.com/courses, and you see the second year undergraduate one course. All right, it's there. You can head over to the website there, and then you can purchase the course to see more examples on applied mechanics, or you can simply join the second year students membership group. All right, I'll leave a link to both my websites and to join the second year membership group for exclusive contents in the video description. All right, so check video description for the link to both my websites and to join the second year membership group. Okay, guys. So if you enjoyed this video as usual, leave a like, hit the like button. All right, so hit the like button, like this video, leave a comment, tell us if you enjoyed this video. If you have a question or observation, leave it in the comment section. Don't forget to subscribe to this channel. If you're yet to subscribe to this channel, please do well to subscribe to this channel and hit the bell icon so that you get notified whenever we upload new content. Then finally, share this video to your friends so that they can also learn. Thank you, and see you in our next class.